To continue our talk about slope, we're going to talk about parallel and perpendicular lines. First, we need to talk about what parallel lines are. Parallel lines are lines that will never touch, they will never intersect. So they're like railroad tracks. They're never going to cross each other. Perpendicular lines do intersect, and the point at which they intersect forms right angles. So the angles made by perpendicular lines are right angles. They're 90 degrees. So all four of these angles would be 90-degree angles. To determine if lines are parallel or not, you need to look at the slope. Parallel lines have the exact same slope. Right? They're going to go up the exact same rate of change, so that means the lines will never cross each other because they're never going to catch up to each other. So if I look at the two equations, I have y equals 3x plus 4, where 3 is my slope, 4 is my y-intercept, and I have y equals 3x minus 2, 3 is my slope, negative 2 is my y-intercept. So identify your slope first. In this first line, my slope, we said our slope was 3. In the second line, we said the slope was 3. Since they are the exact same slope, these lines are parallel. Two lines are the symbol for parallel. I'm going to go ahead and graph these lines just so you can see them on the plane. So if I want to graph 3x plus 4, I need to start with my y-intercept and put a point on 4. And then my slope tells me to rise 3 and go right 1. So it's going to be right there. So if I draw a line through those 2 points, it's going to be about like that. Then to do 3x minus 2, my slope is 3. My y-intercept is negative 2. So I'm going to point on negative 2. Then once again, I'm going up 3, right 1, and putting a dot. So if I draw a line through those 2 points, you can kind of tell how the second line is on the exact same path as the first line. Right? They're not going to catch each other. They're not going to touch. Therefore, they are parallel lines. To determine if lines are perpendicular, you're once again going to have to look at the slope. So where parallel lines have slope that are the exact same, the slope of perpendicular lines are complete opposite. The slope has to be what's called a negative reciprocal, which means they have to have different signs, and one of the slopes has to be completely flipped. So an example of perpendicular lines would be the two equations listed below. Y equals 2/3 x. Our slope here would be 2 over 3. And the second equation, y equals negative 3 over 2x plus 2, our slope would be negative 3 over 2. So as you see, the fractions are completely turned around, completely flipped upside down. We went from 2 over 3 to 3 over 2. And we have one positive and one negative. Both of those things have to happen for this to be perpendicular lines. The fractions have to be flipped, and one of the fractions has to be negative. So to go ahead and graph this, I'm going to graph my y-intercept first on the first line, or the first equation. 2 over 3x plus 3, so that means I want to put a point on my y-intercept, which is 3. Then my slope tells me to go up 2, right 3, put a point, and I can draw a line through those 2 points. My second equation has a y-intercept of 2, so I can put a point on the y-axis at 2. And then it tells me I want to go down 3 and right 2. Should be right there. And I can draw a line through those 2 points. They're completely different from the parallel because obviously these two lines do touch, they do cross, which is what you want for parallel lines. If we took a protractor and measured all 4 of these angles that are made by the intersection, they would all be right angles, which would make these perpendicular lines. Yeah, we need to determine in these examples, determine if these lines are parallel, perpendicular, or just intersecting. So, just a refresher, parallel have to have the exact same slope, perpendicular has to have the negative reciprocal, opposite and flipped. Alright, so if we look at our first one, let's identify the slope on both lines. So the slope of the first line is the number with x, which is 3. The slope of the second line is the number with x, which is 3. Alright, so these would be parallel lines. Remember, those two dashes or two slanted lines stand for parallel. Number 2, let's look for our slopes. We have the first one is the number with x, so negative 9 over 4. The second line has a slope of just 9 over 4. Right, so they're definitely not exactly the same, so they cannot be parallel. So let's see if they can be perpendicular. There's two things you have to have. One of them has to be negative, one has to be positive, which we do have. This one's negative, this one's positive. But the other thing that has to happen is that one of them has to be flipped. If you look at them, this is 9 over 4, this is 9 over 4. So therefore they are not parallel, not perpendicular, they are just intersecting. Then let's look at our number 3, our last one. The slope of our first line is negative 10 over 7. Slope of our second line is 7 over 10. And you can rule parallel out right off the bat because they're definitely not the same. So we need to look see if they can be perpendicular. Go through our two check marks. First is, do we have one negative, one positive, which we do. So that check mark is satisfied. The second is, are the slopes flipped? So this one I have 10 over 7. This one I have 7 over 10. So they are flipped, so therefore they are perpendicular. The sign for perpendicular is an upside down T, right, which means that the lines cross to form a right angle. So parallel lines have slopes that are exact same, and parallel lines never touch. Perpendicular lines have slopes that are opposite and flipped, or negative reciprocals, and they are lines that intersect to form a right angle.